Good afternoon, everyone. Thank you so much for joining us. My name is Katie Rowley. I'm the Outreach Librarian for the NOAA Central Library. And before we kick off today, a few logistics. You are muted as an attendee, so if you have a question or anything is wrong with your computer or your audio or your visuals, you can put that in the question panel and I will help you, try and help you with any of those technical issues. The best way to solve those is usually logging off or Xing out of this platform and just rejoining. And as for questions, if you have a question and it's a pertinent one to what our speaker is saying at the moment, I will interrupt and ask that question. If it's a question that you think can wait until the end when we have a kind of proper Q&A, you can hold on to that question or make a note of that when you type it in. So to get started, today we are talking about topic modeling as a method to speed literature review. Our speaker is one of the library's own, Trevor Riley. He's the head of public services in the library in Silver Spring, and he also leads the research team in the library. And I'm going to turn it over to Trevor.
Thank you so much, Katie. So I'm going to actually turning off my camera so that you guys have a full view of my screen when we get started. As Katie said, my name is Trevor Riley. I'm head of public services, and in my role, I also lead the library's research services. So let's get started here today. We have a fun talk. All right. Okay, so if you're unfamiliar with the research services, first off, I just want to say I encourage you to take a look at our webpage. Katie's going to drop a link here in the chat for you. And our webpage really just goes over the various ways that we can assist your team in your research. On your page, you'll see we have a really awesome new video up that has firsthand, you'll hear firsthand from folks who have worked with us in the past. It's also a place to go if you're interested in requesting a consultation or if you'd like to collaborate with us on a project. And so while it's tempting to talk about the service, I'm really excited about today's talk. So I'm going to end my plug here by saying that our team is made up of some amazingly talented and dedicated research librarians. We're always happy to help with you, whether it's EndNote that you're trying to figure out, or if you're considering writing a systematic literature review, our team is here for you. All right, so if you're here today, you probably know that gathering literature is easy. And if you were in person, I'd be waiting for at least one laugh, but really, that's a joke. It is easy. It's actually too easy. And in fact, if you're looking for a good reading list, you can head on over to Web of Science, and you'll be happy to see that they'll have over 12,000 articles on the topic of climate change and mitigation for you to read. And that's just a very small fraction of the journal titles out there. But seriously, there's going through and gathering large swaths of information today is easy. And that's why they call it a wave of information. And sometimes it feels like you're drowning in it. Today, we're not limited into the physical volumes in our library. We're limited in the time we have to gather and analyze the information that is available. And specifically with peer-reviewed literature, it's very easy to accumulate. And finding relevant literature, however, can feel like a grueling task, especially when it's important enough. And perhaps you may be mandated by law to use the best available science. In almost every field, the current rate of scientific publication significantly outpaces anyone's ability to read and assimilate that information, whether you're a scientist or a policy analyst. The information is also siloed in databases. We have subscription platforms, such as Web of Science. We have subscription databases, such as Aquatic Sciences Fisheries Abstracts. There's open platforms like lens.org, semi-open tools like Dimensions. There's government repositories, and there's unpublished gray literature that's scattered across the web. You also have traditional library print holdings, which can have a vast amount of information. And the list goes on and on of the different resources you have available. If you're not in a research database every day, it can be difficult to remember how each one works. What journals does it cover? what syntax is used. Can I use an asterisk to truncate in this database? You could spend hours going through the documentation and the advanced search. So we all know, really, literature searching and screening is critical to the work we do at NOAA, and it's very time consuming. So what we're going to do today is I'm here to show you how topic modeling can be used to cut down on that time and how it can be applied at various stages to enhance the understanding of a corpus of literature. So that brings us to topic modeling. So what is topic modeling? Topic modeling is a machine learning technique that automatically analyzes text and assigns it to natural groups. What this means in our case is that we can take a large number of documents, feed them through the topic modeling software, and in turn assign those documents to various topic groups. It can be used to discover hidden themes within text, as well as to classify documents into those discovered themes. The topic modeling is not new, it's well published on, and specifically the tool that we use, Swift Review, is also published on. Swift Review is a freely available software. It's approved for use within NOAA by our team, to our team. If you're interested in using it, you most likely have to get IT approval for your use. But again, it's open. So if you just want to tinker around with it, it's easy to install on your personal computer. If you just want to play around with it in your own time. But this presentation won't be about Swift Review itself. There's a number of tools and packages out there to do topic modeling. Swift Review is our tool of choice due to its integration with our screening software, which I'll be presenting on next week. And I'm not going to dive into the details of topic modeling or the specific modeling approaches, but I will say that Swift Review uses LDA, which is latent Dirichlet allocation. It's the most popular algorithm in topic modeling out there, and the joke is it's kind of like the Justin Bieber of topic modeling. So again, the jokes don't go over so well when I'm just talking to my computer screen, but I'm hoping to bring some smiles. All right, so we're going to be taking a look at a few different examples today, and again, all of these are just sample data. Some of them do come from projects we've worked on in the past. The first one we'll be looking at today is just Atlantic cod. We're going to take a look at results from 4 different databases: Web of Science, ASFA, which is Aquatic Sciences Fisheries Abstracts, Dimensions, and Lens. There's just a basic search that was completed for Atlantic cod, and we also have the Latin name and abbreviated. This resulted in 7,000 articles, a little over 7,000 articles after deduplication on title, DOI, and author year combination. I've also pre-screened the data for title and abstract because, again, that's the data that we're going to be modeling off of is title and abstract. And then using an RIS export, I've brought that into Swift Review. For this project, we'll be looking at determining a suitable number of topics when you're doing topic modeling. So we'll look at example of 10, 30, and 100, and we're really just going to explore the data. For the second data set we're going to be looking at, we'll have an example question. So how weather data is currently used in predicting vector-borne diseases, specifically to the Aedes and Culex mosquitoes. And so we'll take a look at how topic modeling can be used. We'll also take a look at a publication heat map, which can show trends over time. We'll look at how topic modeling might be able to help analyze search strings. And then also how it can be used to pre-screen articles for a future title and abstract screening process. And then finally, if we have time to explore further, I did just a basic search again on climate change and mitigation. So we'll jump into Swift Active Screener, just show some functionality, and again, explore the data with some hands-on time there. And that's if we have time. Again, if there are any questions, please feel free to put them in the chat box. Katie will interrupt me. If you don't want to interrupt me, you can save the questions towards the end, and I'm more than happy to open it up at that point. All right. So first off, I just want to show you what Swift Review looks like before we actually take a look at the data that I have pulled out. Let me go down to my notes. We're going to be using Google Sheets because I've taken slices of this data at multiple parts of the iterative process because it takes a lot of time when you're dealing with this number of resources to load these projects. So this is what it looks like. We will jump into it, but for now we're going to be operating just off of Google Sheets. Okay. Once I upload the RIS file for my 7,000 items dealing with Atlantic cod, the first thing I'm going to see is the topic models it develops. So for this particular example, I've broken it into a topic model set of 10. Now for 7,000 articles, that is pretty small. It's not very useful, but you can get an example of, you can see how it, as we go through the 10, the 30, and the 100, you know, finding that kind of like Goldilocks spot. It's different for each project. So for example, in this one, you start looking through some of the terms that it pulls up, and I'm hoping that this is large enough for everybody to see, but I'll read through some of these. So I just highlighted some of the, or bolded some of these words. So in the first topic, we have terms such as climate, marine, change, species, fisheries, fish, management. The second one here, as I've sorted it, we have stock, model, spawning, population, recruitment. This third one has a piece on temperature. Topic number 9 here, again, some topics on temperature, thermal, hypoxia, stress. Topic 3 here, gene expression, genes. And so all of this, you know, not very useful. I wouldn't expect it to be very useful, but you can kind of see what's happening here. So these are the topics, the topic models that it has developed. And again, you're seeing here, this is the crossover between the topic models. So if I'm looking at topic 0, across topic 0, if I'm looking at, you know, COD, topic 8 against 0, you can see how the number of crossover articles fit into each topic model. So let's expand out to a topic model which includes 30. And I've gone ahead and I've highlighted some topic models here that have some reoccurring themes, and they might fit with some of the things a researcher might be interested in looking at. So you see the topic models here that I've highlighted in orange have to deal with early life stages, spawning, larval stages, survival, growth. Here again, topic 25, larvae, development, eggs, hatching. And then we have topic 8 here, spawning, reproductive, egg, fecundity, sperm maturation. So we're seeing some of these topics that really have a lot of crossover with one another. And if you followed, you know, the line, you would actually see that when they cross over, they're going to have them, you know, the most articles that are relevant with one another. And taking a look at this blue one, we have temperature, thermal degrees, cold, warming, tolerance. And so again, you're able to start to see the shape of the corpus. You're starting to be able to understand, you know, what's being published on specific to this species. But again, 7,000 articles trying to fit into 30 topic models, it's kind of difficult, but this is definitely better than where we were at with just 10. So I'm going to break this out even further, and we're going to take a look at what it looks like when we break this corpus of 7,000 articles into 100. So again, I've color-coded these so it's a little easier to see. And again, we'll jump into Swift Review here in a bit. But the green is going to be, again, those early stages, larvae, larval, recruitment. We have early stages, development, embryos, embryonic, juvenile, survival, mortality, recruitment. So you can kind of see here, right, this topic 1 between early stages, larval stages. And then this topic 36 is more juvenile mortality and recruitment. So it's you're starting to see the cross sections of the literature. And let's go down and take a look at the other ones I've highlighted here in green as well. So we have reproductive female spawning. Here we have one that's more recruitment, mortality, biomass, spawning. So you can start to see a lot of these groups that kind of fit together. Let's go back up and take a look at some of the other topic models here. So we have temperature, thermal, again. So you can start to pull some of these together, climate change, marine warming. And then you can actually, beyond just taking a look at the topic model that is developed, you can start to see some of the trends here in the research. So red is, I consider it hot. I would actually prefer to see it like green and red being a low number, but this is the way that it outputs. So you see, if you're looking through these, some of these specific models just have a lot. You can see this top 27, topic 2, topic 3. But if you take a look at them, again, they're not all going to be useful. So obviously this one has a lot of publications, but it's cod, Atlantic, Morhua, Gaddis, study, Elsevier, right? We have Elsevier, rights, reserved. So I think we have a little bit of cleaning in our metadata. I didn't go through and pull out all the copyright statements from the abstracts, but that's what you're gonna get in the data, right? So it's just using that title abstract data. All right, so say for instance, I'm a researcher and I'm interested in one of these topics, and I'm really interested in early stages. So what I've done here, what we'll look at next, is I've actually taken a slice of this, of the 7,000 articles. And so I've taken topic model 1, 5, 11, and 63. All right, so take a look at these. So 1 is development, larvae, early stages, larval stage development. And 11, again, focus on larvae, larval survival, early stages. This one has prey in there and transport, so a little different. We have 5, eggs, spawning, production, offspring, reproductive, and then we have 63, which again has the larval key terms, growth, survival. It also has some other terms in here, which again, when we're working with subject matter experts, it's really awesome to be able to show these topic models because we can get a lot of feedback. DPH, Artemia, and you may or may not be something that the researcher may want to include, but for this instance, this test, I've included this. So let's jump into that cross section of data. And this is a little bit of a different chart here. So I've actually taken those 4 topic categories, and instead of the 7,000 articles, we now have roughly 2,100, 2126. This chart is actually a heat map for publication years. So again, we're taking a look, we have the 100, or actually I broke it into a topic model of 30. So I took just those 4 specific topic models from the 100. And when I reran it, I didn't want to run another 100 groups. I just wanted 30 because again, we're dealing with a smaller set of literature. And for each project, it takes a little bit of testing. But if we take a look at this, we can actually see the number of studies or the number of papers in line with the publication year. So for this, I just broke it down for every 1 year. So this is the year 2000 in column B, 2001, 2002, 2003. And so you can see those numbers across the top. And you see that drop off in 2022, obviously, because we're not through the year. What's nice about dropping this into something like it creates an Excel file, you can create very quick and easy visualizations for the data. Here I just did a total across each of the models, and then you can see the number of publications within each of them. And so again, taking a look at this one, it's probably going to be something that's unuseful, right? Because it has so many of the papers included. And if you take a look over here, it really is. I mean, you have fish, species, life, marine, environmental study, importance, studies early data. So that's not something that would necessarily be useful. However, if we take a look at something like topic 14 here, we actually see a real trend in the number of papers that we have found over the years in this topic. So going from 14, 7, 11, 18
Trevor?
in the early 2000s. Yes.
Trevor, I'm going to interrupt and ask, can Swift Review, can it be used to analyze documents in multiple languages?
So that's not something that we have done. However, it will pull out, let me see if there's an example in here. This is an example where it's pulling together, obviously, items that were in a foreign language. Again, this is just Web of Science, and the majority of the data that we're pulling in is in English. I don't know the specific details for other languages used, but again, because it's co-word occurrence in here, it might actually do a pretty good job. But whoever asked that question, I'd love to tag up with them maybe after the talk and learn more about what they might be trying to do. All right, so I'm gonna continue here. And taking a look at these, a researcher might be able to start to see some of the more specifics when they're taking a look at that larval stage. So we've isolated the 2100 items, and as you go through here, you can start to see both trends in the publications, but also in the literature, again, dealing with different topics. So I'm going to jump over here because this is this is the heat map, and then we're going back to the topic model. So if we're going to continue, yes.
I'm going to interrupt you one more time.
No, it's okay.
Quick clarification, this asker may have missed this, but the terms appearing in the topic model are pulled by Swift from title and abstracts, correct?
That is correct, yes. And that's the only data that we're working with.
Yes, and is there an approval process where certain words like prepositions are removed?
Yes, so the algorithm does have stop words, everything like that. So that has to do with kind of the more in-depth LDA stuff that I'm not getting into today. But yes, there are terms that are not going to be included in here. Obviously, if there wasn't, we'd have a lot of ands, ors, thes, that type of information within these topic models.
Great, thanks.
Yep. All right, so taking a look at this, again, we have these isolated 2126 articles, and for topic 14, we have climate change, or climate and change, it's gonna be together, marine warming effects, impact, species, ocean, ecosystem, and ecosystems. So that topic model has 500 in it. We also have topic 17, we have temperature, acidification, ocean thermal effects, elevated levels, PCO, temperature, and warming. And then you have one that could potentially be useful if your focus is specific to warming and impacts. You have growth, larvae, larval. Those are obviously going to be included because that's a subset of the literature. Temperature, cod survival rates, early effects, and effects. So that could potentially be useful as well. And this is where I'm going to jump into Swift Active Screener, because as much as I can show the usefulness of this here, where there's 500 in this topic model, there's 486 in here, and the crossover is 238 between these two models. It's actually really awesome to see it live in Swift Review. All right, so this was our initial 100 topics when we ran through the 7,000 articles. We took topics, let me resort these. We took topics number 1 number 11, and see how as I add these, it's telling me the total number, right? This is the 702 that were in topic number 1. If I add topic number 11, there's 743 in there. And then we go down and here's topic 5, the eggs spawning, and then we had topic 63. And so here's that 2126 right here of the 7,072 items. I can see a whole list within, because this is LDA, it's a probabilistic association with the different topics. So you can actually see individual items and how they are ranked. Let me hide this health outcomes. And how they are ranked in terms of their matching for these different models. So this one right here matched with 11 first, then 3. So it provides different topics it matches with. So taking these is really easy. I could just export all of these into an RIS file. I'm not going to do it now, but it's actually just, it's really easy to export specific models. I'm going to go in here and I'm going to load our other project. So this is our subset of literature. Okay. So here we have the same models that I had pulled together here in Reduce. We have topic 4, we'll do topic 14 and 17. And again, because we've already narrowed it by that larval, focus, these ones, let's see, 14. Oh, and I already forgot the other note, 14 and 17. I was 7. All right, 14 and 17. So now we can see that the literature dealing with temperature, marine warming, effects, ecosystems, some acidification in there, is 1,000 of these 2,100 articles. I can easily take these and I can export them into an RIS, and then just by exporting these select documents, and then I can open up EndNote. I can load them in there and I can start attaching full text if I want to read those. So it's a very simple process. And when you're dealing with a huge amount of literature, it can speed up the time that that you're having to trudge through things or use specific keywords, greatly. So let's see where we are on time. All right, perfect. Again, in here, you can also read the abstract and go through each individual item. Swift Review can also do screening. This is why you will see this training item and this included column. We don't use Swift Review for screening the literature. We actually use that other Swift Active Screener. But it is a function that is available here. It doesn't have the active learning, which Active Screener has, so that's why we don't use it for this. Let's take a look at the heat maps though. So I'm going to take a look at, and again, I want to see the topic models on the X and Y axis here. And then what I can do is take a look at those two different models that I wanted to look at. So 14 and 17. Ooh. All right, so we have 14 here, and going across, we have 17. So we have topic model 14, topic model 17. That's the one. Those are the ones that we identified, and the crossover between those 238 articles. Let's just take a look at these, just because I've done a lot of talking, and we want to see kind of what's in here. So, fish facing global change, early stages, the lifeline. Ocean warming and hypoxia effect, embryonic growth, fitness level, fitness and survival. Yeah, recommended priorities for research, ecological impacts, ocean and coastal acidification in mid-Atlantic. So you can see how taking a group of, yes.
I got a question.
Absolutely.
So I may have missed it, but when multiple topics are highlighted, does the article list only include articles that belong to all the topics you select, or does it include all articles that belong to any of the topics selected?
Say that one again.
Yeah, it's a little convoluted. So, okay, the article list that you have below, that 1,000 articles or so, does the articles in that list include all the topics you selected, or does it include all articles that belong to any of the topics that are selected?
I almost want to say yes to both because maybe I'm not understanding the question. I'll walk through this just real quick. Okay, so if I select topic 14, topic 14 has 814 articles. If I look here, I have 814 articles out of the 2,100. Now, if I add another, and if I can actually look at all the different topics that it was included in, so I know Trevor, that like this article, yes.
Yes, I think what they're asking then is if the topic 14, climate change, marine warming effects, if the 814 articles include all of those words or just one of those words. And I think it's all, correct?
Yeah.
Those articles have to include all those words.
It's so they're co-occurrence, so it doesn't necessarily have to include every single one. Again, this is because LDA works on probabilistic organization, it assigns them these topics based on co-occurring words within the entire corpus of literature. So it doesn't have to be every single word, but it's a match to those terms and how they're distributed across the corpus. If that
Got it. Yep, that makes sense.
Yeah, okay.
Thank you.
All right, so I was looking at these articles here, and again, so these are really, to find these 238 articles, if that was, again, it's kind of a, we're combining two topics here that are very similar. So to find the ones that are, crossover, maybe not make as much sense. It would probably make more sense for somebody looking at larval stages and climate change, marine warming, to just take 14 and 17 and take all of those articles, the whole 1,000. But now you're only dealing with 1,000 articles. You started with 7,000. Even if you had done searches for keywords in the literature, again, you're not going to find all of these 1,000 articles because, again, it's using the topic modeling and the algorithm to actually probabilistically include these in the specific model. So again, these aren't, they don't have every single one of those keywords. And then you can also do the heat map. I'm trying to remember if you can see it in here. No, you have to actually export it. The tag heat map, and this is where you can do that right into Excel. All right, so I'm actually going to jump in. I'll see if there's any more questions on specifically the Atlantic cod, but then I'm going to jump into the next project.
No questions.
All right, awesome. Okay, so the next project was the prediction of vector-borne diseases, and this is specific to the researcher we were working with is looking at West Nile, but really decided that it would be good to take a look at the entire set of literature out there because they were dealing with more than West Nile in the future. So running the corpus of literature that we found through topic modeling gave us a really good idea of, again, just what the literature was about, what the trends were. And here you can see that I've highlighted a number of topics, and we use this actually to help us better develop our search string because we knew that we were going to be dealing with so many, such a large group of literature. So this was one of our early search strings. And when we ran the results through Swift review, you can see there's a lot here on temperature, transmission, incubation. Here we go. We have climate change against scenarios. Scenarios is a good one. Potential risk, warming impacts. Here we have model and transmission. So we're getting to more of that prediction which is what our researcher really wanted to get to. We have mathematical, mosquito, again, climate, drought. We have some interesting Ecuador, El Nino Southern Oscillation, and so here, and then Nino there. So again, like that's pretty amazing to me. Just thinking about, all the, the literature on, on this topic, and then specifically related to El Nino, Southern Oscillation, weather patterns. It's really, really interesting. And then here you have more. Yes.
Okay, we got a question.
Sure.
How did you set up your initial search? Is it using a database search, exporting the articles based on those search terms, and then the Swift Review program creates its own topics? Or do you have any say on what types of topics you're interested in?
No, the topics are natural. This is it's a unsupervised technique. So it's a text it's just text mining the titles and abstracts. So you have no say in terms of the specific topics. You do have a say in how many topics you want it to create. So again, between really, obviously not one, two and 100, but it's finding the right spot. So no, you do not have any ability to do that. There is a search functionality for keywords, so you can actually use Swift Review if you wanted to do a search. So you can actually develop an advanced search and query all of the sources. But no, that the topic modeling is unsupervised.
Great. I think to answer that first part of the question, though, you just started this with like an initial search string in a database,
yeah, let me show you.
And then exported those results.
Yeah. So this particular data, I put the search string here because this is part of what it helped us do. So we took this search string, I've broken it down into the different themes of the search, really, right? Mosquito, Culex or Aedes. We also have West Nile virus, West Nile fever, Japanese encephalitis, dengue, Rift Valley fever, all, the different viruses. Then we have predict, model, project, risk, algorithm, forecast, right? So this is our initial, one of our early search strings. And then we have weather, climate, meteorology, precipitation. Obviously, a lot of these are truncated. And so we were able to see what the literature looked like with that search string. And that's what's really exciting, about using this at different stages, right? I can use it to screen like we did here, right, for larval stages and maybe temperature effects in cod. But here, we're not really using it for that case. We're using it to maybe further develop our search string. So knowing that the researcher and we spend time going through these topic models with subject matter expert. So looking through these and identifying which of the topics we really felt were the most going to lead us to the most reliable set in the end of resources. So we highlighted those, exported them, and then you can see out of all of those that we had identified for the particular models, in this case, there were 3,200 articles, 221 that we loaded into Swift Review. And by selecting these particular models, we ended up with 2,252, right? So using this search string. After testing out a number of strings and playing around with it, we decided that it would be better to focus more on the modeling. And there was it just felt like this was too much to look at. So even the 2,200 articles. So what we did was played around with the search string a little bit, tested it out, and really scoped it down. So you can see this is much smaller, but we're really just focusing on that prediction, model, projection, algorithm, right? We left out a lot of the other terms like incident or outbreak, warning, transmission, distribution, and decided to see what it would look like when we were just focusing on that terminology for modeling. And so here we actually see that there's a lot more relevant models that came out of this next topic model. And when we combined these and exported all the data, we ended up with, out of the 15 82, we ended up with 1530. So really, what we were looking for, we found that this was much more of a precise search, and we knew we were going in the right direction. And what's nice is it's not like you have to just dump the rest of the articles. This was really to do more keyword extraction. So I can take these, 1,500 articles, or maybe even if I wanted to take, for example, some that are very specific to modeling. Here we go. This one is prediction, forecasting, cases, data. So you could take some that are more specific to that, or this one. This one's even better. Models, data, modeling approach, framework. So you could take, these 877 articles and run them through something else like Lit Searcher or something else that can do keyword extraction. And really, that's more of just a number count on words. It's a little more rudimentary than topic modeling, and you can actually then further develop your own search string, because now you have a good sample of literature that you can pull from. And out of those 877 articles, running those through, you can find more terms that can potentially be used to enhance your search string. And you can also find some really nice exemplar articles that you can use in your evaluation for screening and how many articles were actually pulled from each database. So there's a lot. There's so much more that you can do, with topic modeling. And it brings me to the point that a lot of this is, experimental, even with new methodologies like rapid evidence assessment methods. There's no standardized protocol on how topic modeling can be applied to searching and screening literature for systematic reviews or systematic maps. A lot of this stuff is still being developed. But we know from our use that it can drastically speed up the screening process. All right, let me take a look at my notes and see where I'm at. I think I want to jump into Swift Review again and load up another project, and we can do a little hands-on review. But I will open it up for any questions right now too.
No questions.
All right, awesome. So I'm going to load this next project here. Okay, great. So this last one here, again, on my slides, I put it down, but just in case you need a reminder, this was a Web of Science search that just did the term climate change and mitigation. So that was there was one Boolean operator, the and it was either in the title or the abstract. Those two terms had to be used together, but they could be used together either in the title or the abstract. And again, I ran this through the topic modeling just so you at 100, just so we could play around with it. And I'm happy to click on any of the topic models or to do some searching within here if anybody wants to go down a rabbit hole a little bit and play around. And also just so you can see how Swift Review can handle the data. And as people may be thinking of ideas, or if there's not any, I can just start exploring. I will say that topic modeling I think can be used for a number of projects, but it's not necessarily right for really every project or every part of a project. It really depends on what you're trying to do, and also how transparent how reproducible, and you know, what you're trying to accomplish. A lot of these things can be documented, but for things like keyword extraction, if you're using topic modeling, it's not something you necessarily need to document, because you're going to be using that keyword extraction to build further strings. But you may just be gathering information on a subject for background. You might be a fisheries biologist. You've never worked with groundfish before, but now you've moved up, you've changed positions, and now you're dealing with groundfish. Okay, well, what's the literature out there? You know, what are the major threats? You know, you can read a few articles on the topic, but kind of getting the lay of the land on what the most recent information isn't always easy. Are you trying to understand, you know, a large corpus of literature? Did you walk into a new office and they have a big EndNote library? You don't, there's offices out there with hundreds of thousands of items in their libraries. You could use this to just understand what an office has in that library. You could use it to look at new methodologies. Maybe you're looking at trends and your office is focused on funding. You could even use it for understanding what journals to publish in. Let's just take a look at one of these. Okay, so we have climate. This was climate change and mitigation. All right, one of these, topic 65, we have carbon and we have sequestration. Okay, so you could take a look at this. There's 3,216 articles in here. You could even take, something like this. Again, this is very rudimentary. This is just for testing purposes, but you can see what journals are publishing in this field, in this topic, and it's really interesting. Applied energy, atmospheric environment, and you could go down and there we go. Climate change, that's obvious. We can really get a lot out of this. Environmental and science policy and technology, forests. So again, there are a number of applications that we don't even get into with topic modeling, but it's very powerful. And again, I mentioned testing out search strings. It can be used for that. Or if you're again looking to do a systematic review or systematic map, this can be one of your first steps, not to gather literature necessarily, but to gather groups of literature to then run keyword extraction on and build your search terms for a really nice and robust string that you can apply to various databases. All right, so Katie, I don't know if there are any ideas in the box if you want to explore this data. If not, I can walk through some and just explore. But
yeah, we do have a few questions. I was going to save one of them for the end Q&A, but there's
sure.
a new one that just popped in. Trevor, can you talk more about how the articles are imported into the program? Can you use this on an existing Mendeley and EndNote literature list? And could you show the process from the very beginning through to looking at the heat maps?
Yeah, not a problem. So I'm just going to open up EndNote real quick, just like any other citation management software. I'm just going to grab a short one. So this is for our tutorial here. This was some of the 7,000 articles. So I'm just going to grab a group of literature, and I'm going to export this as an RIS. So Atlantic Cod tutorial, and I'm just going to, it's an RIS, and I'm just going to throw it on my desktop here. Okay, so very small because I don't want active screener or active Swift review, sorry, to be running too long. But now I go in here, I go into file. I'm going to load a reference file. I'm just going to replace it. I don't want to merge, but there might be times where you might want to merge. And I'm going to take a look at my desktop, and I'm going to grab RIS Atlantic Cod tutorial. So I think this was 100. I think I had it set to 100. So we're going to see what 20 articles or something it looks like broken up into 100 models. Or topics. I'm not really sure that's going to look like. All right, here we are. So there are 21 articles. Here's their distribution across these different models, but that's really fast. Obviously, 21 items, and we could see at least what is out of those 21 random articles, what was the main topic? Fish study significant earlier, agree. Yeah, so kind of useless here, right? But you get the point there. Once you have a project, because some of the files can take so long, you can save a project, and that's the same thing that creates these STP. These STP files. So in this case, like the Atlantic cod, I have the 100 that we looked at, and then we have the tutorial here. So that's the way you load an RIS file. It's really nice and simple.
And then you would just look at the Heatmap Browser and the tab above, correct?
Yeah. So this drop down does have. I stick with topic models. Siom, who created Swift Review, has worked a lot with NIH and them. So they do have like health outcomes, exposures, evidence streams, and those are really not necessarily related to fields that we're dealing with, but they are out there. It can also take mesh terms and work with those. So, but yeah, topic models here, and then under the Heatmap Browser, you would just want to change that if you wanted to see the cross correlations. You just change it to topic models and columns and rows, and then you have the nice heat map here. If you want to create a publication heat map, it's very easy. Again, you just go in here and you select topic models. You select the years that you want covered. So you could do from 2015 to 2022, and the bin size is just the number of years. So every one cell or one column is a year, or if you wanted it for 2 years combined, sometimes when you're dealing with a large range of years, that can be helpful. And then you just put it in an Excel file, and it will actually add. It's really nice. It adds tabs to the Excel file, so you can use one single Excel file, and it will provide you with all of the data. Let me open that up. Give you an example.
Also, Trevor, when and how do you choose how many models to create?
Yeah, so that's a really good question. It takes a lot of trial and error. Yeah, again, I kind of referred back to earlier as kind of it's like the Goldilocks principle. It's like too hot, too cold. In a lot of these cases, see which one did I load here. This is the 30. Go back to my 100 so I know which one I'm talking about. It really depends on how many articles you're loading up. Like that's the first consideration that I would take. If I'm loading thousands of articles, and again, is it tens of thousands, or maybe is it 2,000? It kind of just depends. And you really, there's no right answer to it. You really have to just play around with trial and error. But what's nice again is you could potentially run a topic model at 100 topics, for example. So you could then take a subset of literature from those 100 models. You could export those, and then you could run a topic model at maybe 50, right? And then you could identify potential topics that again fit with what you're looking for, and you could export those. And if you really wanted to get deep into this, I mean, this is stuff that I don't have time to do, but I wish I could. You could actually evaluate how well the selections you made at a 50 topics topic model versus the 100 is, and how much of the literature that you wanted to capture in the end was captured within those topics. So there's really a whole lot you could do to analyze, maybe what the best number is, but a lot of trial and error. Not a
All right,
lot. It's a little trial and error.
there is a couple more questions. Within Swift Review, can you filter on NOAA publications or articles, or is that something you would have to do before loading?
Yeah, that would be something that you would have to do prior to loading. In the titles and abstracts, you're not necessarily, maybe 0.01% is going to have any information about funded or anything like that. If you're looking for authors, it's not going to have affiliation. That's something you would need to do prior to bringing the information into Swift. That being said, there are ways to do that, and our team has worked with teams to identify funded articles, and our bibliometrics team does a lot with that as well.
Awesome. So we have one last question that I have here. Do you have any examples or use cases where this data or this product, this Swift Review, is being used within NOAA, and who's using it, and has it been, kind of presented or shared anywhere in NOAA or beyond?
We're the only entity that I know of, the NOAA Central Library, that is using this particular software, and I haven't seen any other presentations on topic modeling per se. That being said, we've been using this software. I've used it personally in probably somewhere between 5 and 10 projects. Again, a lot of these methodologies and tools are really new to us, and we're always just trying to explore how to speed up our process, because we're a really busy team. But yeah, to answer the question, I don't know of any other group internal to NOAA. There are other groups outside of NOAA, and again, this software has been published on in terms of its use for some of these methods, mainly screening.
Trevor, I would kind of push back on that and say, like, researchers within NOAA are using Swift Review, but they're using it in conjunction with us, correct?
Yeah. So the projects that I've used Swift Review on for topic modeling, it's always been, that was the first time that group or that person had used Swift Review. So yes, I mean, we're using it on those particular projects. They may have gone on and used it for other things, but in terms of somebody approaching, at least me or anyone on the team, I haven't heard of somebody approaching us with, hey, I use Swift Review for this. There is one project, I don't know how much they're kind of advertising the use or anything, but they're looking at, I know the NRDD is taking data and trying to apply it for doing topic modeling, to understand, again, like, what are all these projects, or what correlate with one another. So yeah, there is stuff happening, but nothing really that's like in place and running that I know of.
All right, thanks, Trevor. I was just thinking of the groups that have worked with us and then gone on to do presentations about using the software to get their results. So
Swift
I know
Active Screener. Yeah, I think Swift Active Screener is the more solidified one that people have. Like, there was an AMS presentation from folks that we worked with to do Swift Active Screener, which is the presentation next week.
Good segue. So thank you all for joining us today. We will have a sort of follow-up, but not quite the same presentation next Thursday at noon as well. And this will be on Swift Active Screener, correct, Trevor?
Yes, and I'll give a 30-second on that. Swift Active Screener uses active learning, active machine learning to re-rank articles. So once you have your corpus of literature and you need to screen it for inclusion, exclusion, as you include or exclude articles, the algorithm re-ranks the corpus of literature, so you can actually screen a large number of articles in a short period of time. because you don't need to review anything that is not relevant.
Great. Thanks, Trevor. And thank you, everyone. We hope to see you next week. And with that, our hour is up. Take care and enjoy the rest of your Thursday.